Using a Python program, we will train a model with the truth table of digital inputs and outputs, and then we will pass the weights of the trained neurons to an ESP2866 using the Platformio extension of Visual Studio Code. Finally, we will mount it on a breadboard to check its operation. We will create a working directory training. Now we will download the training file and the Python training and production programs. Python programs use high-level matrix operations. They do not use direct instructions to the CPU and much less to the GPU, which is why they are slower. We have created them with the help of Copilot from Visual Studio Code. They allow any number of digital inputs and outputs. Since they are programs, your PC security will probably ask for your authorization to download them. We will copy these files into the created directory. As you can see, the training file contains 3 inputs and 1 output. We have determined that the output will be activated only when there are 2 active inputs, but you could put any equivalents. It is important that at the end of each line and the table there are no spaces or line breaks. We copy the address of our directory. Let's open a terminal, in this case PowerShell. We type cd space, then paste the address and enter. Now we launch training by typing python training.py. By testing, the appropriate number for each table can be found. The maximum number of iterations will depend on how complicated the table is. When the error falls below 2 decimal places, the model is trained, then 2 files are created with the weights of the hidden and output neurons. As we can see, a row is created for each neuron with the weights of each of its inputs. In the hidden layer we have the weights of the 3 external inputs, and in the output layer the weights of the neurons in the hidden layer, 5 in our case. Now we check the training with the production program. This program uses the weight files created in the training. We check with the truth table. Next we will introduce the created tables into an ESP01, and then we will load a program to manage the inputs and outputs with the data from these tables. We will use Visual Studio Code, and within it we will have to have the Platformio extension. We open Platformio, create a new project. We name it and choose the board. We change the flash mode parameter to doubt, in order to be able to flash all the boards. We will also incorporate the litlefs file system to store the weight files. Adding this line to platformio.ini. We have autosave activated. We create a new directory called data that will contain the files to be transferred to the board. We copy the weight files created previously to this directory. Let's connect the board. In our case, we use an ESP01 with a modified USB to be able to flash. As you can see, we have soldered some cables to pins 1 and 3 joined through a 200 ohm resistor. They could be connected directly, but it is safer this way. To transfer the files to the ESP, we select the Platformio icon, create the file system image and upload them. After uploading them, we disconnect the board. Now we download the program that will control the board. It is written in Arduino C language and you can naturally modify it according to your needs. We will save it in the src directory, which already contains a main.cpp file. We must replace it. We compile for testing. We reconnect the board. Once the compilation is complete, we flash the board. We have made the following connections to check the operation of our circuit. As you can see, whenever we have 2 buttons pressed, the LED lights up, but if it is only one or all 3 or none of them, it does not light up, which is what we have entered into the truth table. Doing it with training has only been an exercise, since the logic is easy to implement with while. Regards.